In this video, I'm going to be describing how to use the fundamental theorem of algebra to find all the zeros of a polynomial. The fundamental theorem of algebra basically says that if a polynomial has a degree of n, basically a number that's bigger than 0, then the polynomial is going to have that many zeros. For example, if I say that there's a polynomial that has x to the fourth plus x squared plus x minus 10. If you look at the highest degree, which is 4, that means you will have 4 zeros. So therefore, there will be 4 zeros. They could be real zeros, rational zeros, they could be square roots, they could be imaginary, but there's going to be 4 of them. There could be a multiplicity, but there will be the same number. Whatever the highest degree is, that is the number of zeros you're going to have. So you can always be able to figure out whether you have found all the zeros that you needed to or not in a polynomial based off the highest degree. So to find all the zeros, the steps are: first, factor if you can. Always look for a common factor first, or see if you can factor into 2 parentheses. Once you've done that, or if you can't do that, then go to synthetic division. Once you've done that, if you've gotten down to a quadratic, then either solve for x or use the quadratic formula or factor to find the last 2 zeros. So for example, find the zeros of this function. First, I notice there's actually something in common. They have an x in both terms, so I'm going to factor out an x, and I'm left with x squared plus 4. That means I can actually go ahead and set both these equal to 0. So x equals 0 and x squared plus 4 equals 0. Well, we know one of our zeros, it is 0. At this point, we can actually solve for x. So to solve, I would subtract 4 on both sides, and then take the square root. When you take the square root of both sides, you'll get x equals plus or minus 2i, because the square root of 4 is 2, and the square root of a negative is 2i. So therefore, your final answers are going to be 2i, negative 2i, and your 0. Now, this was an x to the third. We found 3 zeros, which means we have found all the zeros that we've needed to find. So in this case, to find all the zeros, there's 2 ways you can do this. You can either factor this, or you can use synthetic division. So if I use synthetic division, all the factors of 81 are going to be 81, 9, and 1, 3, and 27. These are all the factors. So if I use a shelf, there is no x cubed, so I need a placeholder. There's no x squared, so I need a placeholder. There's no x, so I need a placeholder. And then there's 81. So I'm going to try to use the number 3 just to start out with. If I plug in 1, I'll get 3. I add, get 3. Multiply, I'll get 9. Add, I'll get 9. Multiply, I get 27. Add, I'll get 27. Multiply, I'll get 81. And I did find a remainder. It is 0. So we know that 3 is one of our zeros. Now, I'm going to take what my answer is. We're not at a quadratic yet because there's 4 coefficients. We need 3 coefficients. So I know that 3 worked. I'm now going to see if negative 3 works. So bring down my 1, multiply. That's going to give me a 0. Multiply, that gives me 0. Add, that gives me 9. Multiply, that gives you negative 27. And I did find another remainder of 0. So I now know that negative 3 works. At this point, I have 3 coefficients. So I'm going to rewrite this as a function. This is my constant. This is the coefficient in front of x. This is the coefficient in front of x squared. So this is x squared plus 9. There is no x because there was a 0. I can now set this equal to 0 by subtracting 9. So I'll get negative 9 equals x squared. And then to take the square root, I'll get plus or minus. Don't forget, anytime they take square root, plus or minus. The square root of negative 9 is going to be 3i, because the square root of a negative is I, and the square root of 9 is 3. So therefore, my other 2 zeros would be 3i and a negative 3i. Now, I found 4 zeros. My highest degree is a 4, which means I found all 4 zeros. Find all zeros of this function and write them as the product of a linear factor, meaning we're going to find the zeros and then we're just going to rewrite those zeros as a list of factors. So I am not sure. Okay, the possible rational zeros are going to be plus or minus 8, 4, 2, and 1, because those are all the factors of 8. There is no x to the 4, so I need a placeholder. Do not forget the placeholders. Okay, I'm just going to try 1. Let's see what happens. I plug in 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, that worked great. I got a remainder of 0, which means I know that one of my zeros is 1. I'm looking for 5 zeros. Okay, so I'm going to take what was left and do it again. So in this case, you know what? I'm going to try 1 again, because you can try the same number more than time. It means that you'll have a multiplicity if that happens. So I'm going to plug in 1, multiply, add them together to get 2, multiply, add them together to get 4, multiply, add them together to get 8, multiply, and it actually worked. So I know that 1 actually happened twice. Okay. Now I am left with all positive numbers, so I know that I can't plug in another positive number, because if they're all positive and I plug in a positive number, there's no way I can get 0. I'm going to have to try a negative. So let's try -1. If I bring down the 1 and multiply to get -1, add them to get 1, multiply to get -1, add to get 3, multiply to get -3. Nope, that is not going to work. So let's try -2. Bring down the 1, multiply, that adds to give me 0, multiply to get 0, add to get 4, multiply to get -8. There you go. I found another remainder of 0. So -2 was also a 0. We're down to 3 coefficients. Remember, the remainder one doesn't count. 3 coefficients, which means I can write this as a quadratic. This represents my constant. This represents the coefficient of x squared, which means this is x squared plus 4. I can now set this equal to 0, which means I can subtract 4 and then take the square root, so I'll get plus or minus 2i, because the square root of 4 is 2, and the square root of a negative gives me I. So I now know that 2i and a -2i also work. Now let's count them up. I have 1, 2, 3, 4, 5 zeros. This was an x to the 5th, which means we found all of our zeros. This is the zeros. To find them as a product of linear factors, it means I'm going to take them, and if 1 is a 0, then x minus 1 was a factor. You change the sign. If 1 was a 0, x minus 1 again was a factor. If -2 was a 0, then x plus 2 was a factor. If 2i was a 0, then x minus 2i was a factor. And if -2i was a 0, then x plus 2i was a factor. Now you can write it like this, or you can write it like this, because 1 was a multiplicity of 2, and then you can rewrite the others. Can be written the same way. Oops, that should be a parentheses of that. And this, again, remember, multiplicity at 1. Now, the conjugate of a pair, we talked about the conjugate of a plus b is a minus b, meaning if x equals 5i is a 0, then x equals -5i is also a 0. If x equals 2 plus 3i is a 0, then x equals 2 minus 3i is also a 0. The way you would write this is the fact that, okay, I tell you that you have a 0 at 2, so we know that x equals 2 is a 0. We know that there's also a 0 at 3i, but based off what we just learned, that means if 3i is a 0, then its conjugate is also a 0. Regardless if it was written, it has to also be a 0, which means x equals a negative 3i is also a 0. And the way to find the polynomial is you write this as factors. So if x equals 2 is a 0, then x minus 2 is a factor. If 3i is a 0, then minus 3i is a factor. And if negative 3i is a 0, then x plus 3i is a factor. Now in this case, here's what I would do. I would first FOIL the i's together. So I'm going to just bring down the x minus 2. From here, if I was to FOIL this, I would get x squared plus 3ix minus 3ix minus 9i squared. The two middle terms cancel, leaving me x squared plus 9. Why plus 9? Is because x squared is the number negative 1. Negative 9 times negative 1 gives you a positive 9. And now you can FOIL one last time. So x times x squared is x cubed. X times 9 is 9x. Negative 2 times x is negative 2x squared. Negative 2 times 9 is negative 18. The only last step is clean it up by making sure that the degrees are in decreasing order. And that is your polynomial from the given zeros. You also can find the rest of the zeros given one of your zeros. Well, if we know that 5i is a 0, we also know that negative 5i is a 0. So x minus 5i and x plus 5i is a 0, which means x squared plus 5ix minus 5ix minus 25i squared. The two cancel, leaving you x squared plus 25, because remember, I squared is negative 1. Negative 25 times negative is a positive 25. Therefore, we know that x squared plus 25 can be factored. Because if 5i and negative 5i are zeros, that means x squared plus 25 can actually be factored out of here. This is where you have to go back to long division, though, because we have an exponent. So x squared plus 25 goes into 2x cubed plus 3x squared plus 50x plus 75. Okay, x squared plus 2x cubed. X squared goes into this first. 1 goes into 2 twice, and x squared goes into x cubed x times, so this is going to be a 2x, because x squared times x is 2x cubed. X squared times 2 gives you 2x cubed. So 2x times 25 is 50x. 2x times x squared is 2x cubed. Now we're subtracting, so we got to change the signs. 2x cubed and negative 2x cubed cancel. I bring down the 3x squared. 50x and negative 50x also cancel, and then I bring down the 75. X squared goes into 3x squared 3 times, because x squared goes into x squared once, and then 1 goes into 3 times. 3 times 25 is 75. 3 times x squared is 3x squared. But you are subtracting, so you got to change the signs. That goes to 0, that goes to 0. And so your last factor is a 2x plus 3. If you set that equals 0, you'll actually find your 0. So you would subtract 3 and divide by 2, and you get your last 0, which is negative 3 halves. So if 5i is a 0, we know that negative 5i was a 0, and we just determined that negative 3 halves was also a 0. These are 3 zeros. Your highest degree was a 3, and so you found all of your answers.